This is the 2020 Cleveland State University Fluid-Powered Vehicle. It was built over the past year by our team of senior mechanical engineering students, Angela Rodriguez, Sarah Smith, Naik Yusufi, Jacob Landry, and myself, Ellen Ray. The Cleveland State bike took home the first place overall championship in this year's NFPA Fluid Power Vehicle competition. This is a national competition where student teams from universities from across the country spend a year designing and building a human hydraulic-powered vehicle to race in a final competition. This year, one of our main design objectives was to minimize overall weight. We decided to build a custom frame using carbon fiber tubing, which is a much lighter alternative to steel. Before construction, we created a conservative model of the vehicle loading and used FEA analysis to check the stress and deflection in our frame. Another design focus was on simple component mounting. We integrated the hydraulic reservoir as a structural member in our frame. Our design includes a mount underneath the reservoir for the hydraulic motor. The top of the reservoir has a dual-purpose bracket that supports the top of the seat and serves as a mount for the accumulator. This year, we designed custom rear wheel mounts using a quick-release style to allow for easy maintenance on the rear hub. We opted for disc brakes to ensure quick, reliable stopping even at high speeds. The rear wheel brackets were prototyped using 3D printing to ensure a good fit to the frame and caliper brake assembly. We also looked at minimizing frictional losses due to wheel slip while turning. We created a MATLAB program to optimize a trapezoidal steering linkage to closely approximate the Ackerman steering condition. This condition gives the ideal relative angles of the wheels during turning to eliminate slip and reduce frictional losses. For this year's hydraulic circuit, we focused on creating safe and user-friendly operation. We also set out to create a versatile charging process that included regenerative braking. This is our hydraulic circuit. Using only 3 valves, it is simple but still provides a great deal of versatility in operation. In the pedal charge configuration, the rider can manually charge the accumulator by pedaling. In accumulator drive, the rider can power the bike using stored pressure by actuating a ball valve. With pedal drive, the vehicle can be driven directly through pedaling. This can be done even with pressure in the accumulator. To apply the regenerative brake, the rear solenoid valve is closed using the button on the handlebar. This redirects flow and uses the inertia from the rear wheel to charge the accumulator while the bike stops. We selected a carbon fiber bladder-style accumulator because of its lightweight and high efficiency. For our pump and motor, we use fixed displacement piston pumps because of their high speed and efficiency. A solenoid valve was selected for the inlet to the tank because it allowed us to cut down on the amount of hydraulic line while still maintaining rider safety and usability. We designed a simple electrical circuit to actuate this valve. A normally open solenoid was chosen to conserve battery life and ensure that the rider will never be stranded. We kicked off building the bike by constructing our custom carbon fiber frame. We drilled carbon tubes to fit aluminum joints and fabricated some of our own connectors. The entire team got together to spoke our own front wheels to ensure that they could hold the weight of the vehicle. We used a water jet to cut aluminum for our mounts and hydraulic reservoir. The hydraulic reservoir was constructed using 6061 T6 aluminum panels that were carefully TIG welded together. We fabricated custom brackets to mount the hydraulic circuit in a configuration that maintained easy operation and minimized hose length. Once the bike was complete, we used a power trainer for testing and determined that optimal vehicle performance is achieved with a 1000 psi accumulator precharge and a 3.75 rear-end gear ratio. Our final vehicle has a curb weight of 171 pounds, including oil and battery. It has a top speed of 27 miles per hour and completes a 600-foot sprint in 11.4 seconds. Despite increased accumulator restrictions, this is 3 seconds faster than the winning bike from last year's competition. Over the past year, our team has worked together to create an innovative fluid-powered vehicle. Our design focused on efficient use of energy. We reduced weight by creating a custom carbon frame with an integrated hydraulic reservoir. We reduced frictional loss through optimizing our steering mechanism and hydraulic circuit. Our top priority was safety and rider usability. We included quick-release rear wheel mounts and an easily accessible regenerative braking system. With all of our hard work, the vehicle we created brought home the first place overall championship in this year's NFPA Fluid Power Vehicle competition.